So hey guys, let's participate in today's Div 2 contest. In case where gear I has I each wants to arrange them in a row. After he arranges them, Steve will spin the leftmost gear at a speed of 1 revolution per second for each of the other gears. Let X be the number of teeth. Okay. Collection of n gears. N gears are there for each gear. It has this many teeth, and after he arranges them, Steve will spin leftmost gear at a speed of 1 revolution per second. For each of the other gears, let X be the number of teeth. Okay, so this is the number of teeth for each of the other gear. Okay, that be the side be the speed of the gear to its left. Y is towards its left, and Z be the speed of the gear to its left. Okay, so here let's say one I is present here. Let's say X gears, and the Y gears are present over here, and the speed of this is Z speed. Okay, Z speed will be the speed of the gear to its left, then its speed will be Y by X into Z. Okay, so the speed of this would be Y by X into Z. Let's say speed. Okay, and speed of 1 revolution per second. Rightmost gears spins at a speed of 1 revolution per second. Determine whether Steve can rearrange the gears into a satisfactory. Okay, he wants the rightmost gear to have the speed of 1. Okay. Each test case contains multiple test cases. In first one, a single integer, the number of gears Steve has. The second one contains test case n gears. Okay, and integers, that is the number of teeth in that particular gear. Yes or no? Yes, we have to return yes or no. Okay, so let's see this first test case. So here we have this array of length 2 for in the first test case. The second gear will always spin at 5 by 5 speed into 1 into 1. What is 1? 1 is the Z, which is the speed of that gear. It's quite confusing actually. Okay, 5 by 5 into 1. which means that y by x y is the number of state and x is for the current into z revolutions per second into z revolutions per second. The speed of the gear towards its left. Okay, I think I'm getting a gist. So here we will arrange 6 like the two sixes at the end, then I'll get 6 by 6, which is equal to 1, or I would say the second last and third last element should be the same. Here it will be no, the frequency is greater than or equal to 2, which is equal to yes. Okay, one possible arrangement is 6396, then it would be 6 by 3 into 1, which is 2 revolution per second. Okay, the third gear spins at 3 by 9 into 2, which is 2 by 3. Okay. It is said that the speed of the first gear is always 1. So the speed of first gear is always 1, and we can rearrange our elements. So 6396. It is said that the speed of the first gear is 1, and then for every other element we can calculate the speed as the speed of this by that is the number of gears here by the number of gears which are present at this position I. So that we can do a of I minus 1 upon a of I, and in this manner we can divide in, and then we will multiply it by z, that is the speed of this element. So what if I rearrange it somewhat like this? Let's say here it is 3 6 6 9. Then in that case, for this the speed would be the teeth over here, that is 6 by 6 into z, that is the speed of this element. So the speed of this would be simply, it would be based on this elements, and here it should be 1, which means that this element should definitely be same, and then I want this speed factor which should be 1, but for this element the speed would be this by this into speed of this. Great. Into speed of this. Okay. Okay, so two elements would give me the correct answer. Why? Because I can arrange these elements here. Okay, I think I'm getting the answer. I think I got the answer. Let's see. Come on, come on. Why it is taking so much time to build, man? Length of this is 2 or greater than this. Okay. Okay. If I have 2, if the length is 4, then it should be 2. If the length is greater than 4, so this by this into this. So it should be greater than 1 or it should be greater than 2. If this is again the case, then it should be 1 somewhere. 1 by something like this. Yes, yes, no, yes, no. Yes, yes, no, yes, no. But I'm a bit confused as I have not proved this correctly. Okay. Still lives in a village with another villagers. Unfortunately, due to disputes over the distribution of emeralds, one of the other villages are friends. Okay. So Steve can perform the following operation any number of times. Select 2 villagers ing and give them maximum among that grumpiness emeralds to share. Okay. Both of them grumpiness decreases by the minimum. Okay. Okay. Steve lives in a village with an other villagers. Unfortunately, due to disputes over the distribution of emeralds, none of those villagers are friends with any other villager. Furthermore, village initially has combinations of GI. Steve can perform the following operation any number of times. So he can choose 2 villagers I and J and give them max of GI and GJ emeralds to share. Okay. Both of their grumpiness decreases by min. Okay. Min of these values and they become friends. Okay. Okay, we'll increase by the max and then decrease the minimum of them with each other if they weren't already friends with each other. If they weren't already, Steve wishes to make every villager friends with every other which yeah, okay, possibly through some intermediate friendships. Okay, nice. That is, from any villager you can follow a path of friendship to reach any other villager since he does not want to inflate the village economy so much. Okay. Calculate the minimum number of emeralds he must give away to accomplish this. Okay, second and contingency. So we have to justify this. So we want a solution of n log n at max. Okay. For each test case of synchronizing minimum number of emeralds, Steve must give away to make everyone friends. Okay, let's see the examples. The first case, the test case, the only valid operation is 1 and 2. Yeah. So here it will increase by 2 emeralds and they become friends. Max of this, and what do we do? Both of their grumpiness decreases by this. Okay. 2152. Here in the second test case, one optimal sequence of operations is, what is there? 2152. And okay, let's write it down. We have something like 2 1 5 and 2. One optimal sequence of operation is 1 and 3. So I'll select 1 and 3 and then I'll reduce it. I'll first give them 5 and 5 and then wait, 1 and 3 gives civilization max emeralds and then their grumpiness decreases by 2 5, which is 2. Now village's grumpiness is what? Yeah, so it would be 0 1 3 and 2, and the emeralds received in this case is 5, because 5 was the maximum among that values. Okay, now I have to again choose 2 elements and I want to keep it repeating. What is the end goal here? What we have to minimize? Minimum number of emeralds. Steve must give away. Minimum number of emeralds Steve must give away. Okay, so the minimum number of emeralds should be basically, it should be, the number of emeralds should be if I take these 2 elements, it will take the max of this. Okay, and this will reduce to 3. Then for all the elements I'll take the max, which is 3. And what if it gets 0? So it can't be 0 anytime, because 2 1 5 2, first we choose this and this, so it becomes 0 1. Here it would be 3 2 and pk plus 5. Then I choose this 2 larger elements, so it would plus 3 and it will get 2 0 1 0. Then here what I can do is I can choose these 2 remaining ones, and then in this case I'll get plus 2 and it will decrease by 0, and here it will be 1. So let's say again we will choose these elements. I'll get plus 1, but do I need to select this? Yes, these are already friends, so there is no point in selecting this. 5 6 7 8 9 10, is it? No. Okay, why? Because these were friends, then we made these guys friends, so now these all are friends, so I want to add this to any of this. So if I choose this, as this is having the minimum value, so I'll increase it by I see. No, it is still not a viable option. 2152. If I take this maximum element always and I pair it with the second maximum element, then my answer gets increased by 5 like the maximum element, and this get decreased by the minimum element. So now this is a pair, so we have to always decrease the maximum. We have maximum that we can decrease. So if I pair this with this and again this with this, then it will give me maximum which is 3, which I don't want, and again this will give me +1. But what, after this first operation I pair this guy with this, so it would be 5 + 1, like the smaller one. I'll pair this, and the reason for pairing it with the smaller guy is I'll only get this many emeralds and this many emeralds, because this is the maximum. This is the maximum. Is there any pattern over here? What if I pair this with this? So it will give this emeralds, but it will make this 0. So +5, and we will get only 4, which is still having a chance of giving the villagers more emeralds. Let's try again. I'll always take the maximum first so that it will get convert to some lower value. So here I'll get gain of +5 and it will get 3 as I pair it with 2, so 2 gets 0. Then I have 0 1 3 2. Again, if I take the maximum guy and placed it with the second max, I'll have a gain, but I don't want to connect it with this, as this is already connected. So I can think of these other values. So let's take this value. Now if I pair with some smaller guy, then I will add this as the answer. Okay, so I'll get a gain of +1, and again I have remaining this element, so again I'll pair it with a smaller guy so that this will be the gain. Okay, so for all the pairs I'll just get the smaller guys. Okay, so let's say if I have this in sorted manner, then what I'll do is first I'll pair this with this guy, the second maximum, so that I'll get the answer of this guy, and these two are paired. Now what I'll do is I'll take the minimum from this side and I'll keep pairing it. Okay, so it becomes 0 and this becomes 5. Okay, can I count the minimum? While I'm going here, I'll count the minimum, which is 0, so I can pair it with this guy, and then again the minimum would be still 0, but I have +5 gain in the first part. In the second part I get a gain of this. Then again, currently I have the minimum as 0, and here it is also 0. So one part will always get 0, right? The minimum one will always get 0. So after the first one, after the first iteration, for every other guys I can just pair it with this guy, so it would be the maximum among the array, maximum element among the array, plus the sum of small the remaining smaller n by 2 elements. Let's check this. It would be the maximum element from the array, which is 2 here in this case, but since this is having only 2 values, we can just always pair it. If we have 3 guys, still we can, if we have 3 guys, then still we are doing the pairing of this. Then for all the other guys, I can just pair it with 0. Okay, so it would be the same for all the test cases. So here the maximum would be 5, and let's say I sorted first, so it would be 1 2 2 5, and then if I take this element as the maximum, so I would be having a gain of +5. Then I'll be pairing it with the second guy, so the sum of these would be my answer. So it is +3, and which is 8. So I pair it with this, so it'd be +1. And what about this? No, but this is not working. Fine, what we do is, it would be 2 1 5 2. Here I paired this with this, it would be +5, so it became 0 1. Here it would be 3 2, and then I pair 1 and 2, it gave me +2. Okay, so this is a pairing, okay, so I'll get something like 0 1 1. Here it will be 0 3, and here it would be 1 0 0 3 1. And after this I'll add, what will I add? 1 with 0, so that it will give me 1 + 1, 4 elements. Then I got 2 elements. Oh, so it got 0, so I can anyways pair these guys with having 0 values. So in the first part, I got the maximum, I paired it with some another element, let's say n-1, so it became 0. Then I have again 2 more elements, so what I can do is I can pair these guys. I'll pair these guys. So again, if I pair it with this, what if I pair it like this? Then again I got one element 0, and I add this element, which is this is n-1 element, n-3 element, and let's say I have one more element here. Then for these guys we can pair it with the zeros. Let's see if I have 2 more elements, I'll again pair them, so that I'll get something like n-5. And what if one extra element is present? And now for pairing this, for each pairs can be paired with, these pairs can be paired with 0 cost, because these are having 0 values in common. So this remaining element can be paired with, okay, with another element, and its cost will get included. Okay, so if we apply this same on this array 1 2 2 5, then what we will do is, first let's say pair, we will pair this, we will get +5. We will pair this, so we get here as +2. Then it would be 0. Here it would be 2 minus 1, which is 1. 2 minus 2, which is 0, because the minimum this is 2. So here it would be 3. Now for this guys, I can just pair this. Okay, so again for this, for all this, let's say these values are simply 10 10 10 and 10, so I can pair these guys. So the max so answer would be 10 plus 10, and it would be 0 10 10 10. Again pair these guys, so it would be 0 10 0 10, and let's say I have now plus 10. Now I can pair these groups, and the answer would be 20 in this case. So the answer would be 20 in this case. 1 2 3 4 5. Now here I consider this 4 guys. Now if extra one is present, I have nothing to pair with it, so I'll just add this in my answer, and this should be the minimum guy always. This should always be the minimum guy. Okay, now this is definitely correct. Let's try this last test case also. 1 1 3 4 5 and 9. If I pair this, so it would be simply 0 4, and we have 0 4, sorry 0 1 and 0 4, so it would be a gain of plus 9, and here it would be plus 4, and then we can pair this guys. It was paired, this was paired, and we can pair this, and we have 1 1, so we can pair this, so it would be plus 1 again, and then we can pair this, so it would be 9 10 11 12 13 plus 1 14. Yes, this is the answer. So let's say again we have the same thing. Let's say first we sort this array, so sort this, and then we will check if our array length is odd or not. If 0, let's say here we have boolean false, then if it is not equal, basically it is not equal to 0, then what we will do is we will simply set our flag to true, and a flag true means that we will always consider the first element in our answer. So if the flag is true, then I can do answer plus equal to AR of that 0th element. Okay, then I'll start from the second element. So if this is the case, let's say I'll initialize the start 0. Now it's equal to 1 in this case. For equal to st and I is plus n, I'll do I plus. Simply what I'll do is I'll take a jump of 2 values. So for this, first I'll add the minimum among them. It would be simply out of this ith element, of this ith element, and it would be added in our result, and then we will do I plus equal to 2, and I can just output our answer. For this case, what we have is it would be 0, and we will do plus this, it would be correct. 1 3. Okay, why it is 1 3? We want the maximum guy, isn't it? Maximum. If I'm pairing this and this, I should get the next guy maximum, right? This and this, if I'm pairing, I plus 1 should be maximum. So I'll start it from not from 1 but from 2, and I'll just get the answer. So it would be something like, let's say we have this values, and let's say we have odd value, so we will start from this element because this is greater. The fashion is like this, so we will take this, then we will go plus 2, we will go here and we will take this. So this and this will be added in our answer, and this will be the first guy if it is having odd values. What if we have a case like this? If we have two elements, then basically this is the answer always. If we have three elements, we will add this in our answer and this in our answer, because we will pair this. It will get one element will get 0, we will pair over this. Great. So if simply if n equal to 2, then we have our dot print ln of 0 plus arr of 1, and we can just return from here. And I assume that the array length is never 1. Yeah, it is 1. So if that is the case, then I can do simply as if n equal to 1, then we have our dot print ln 1 arr of 0 return. Okay, so this will give me the answer 2 7, and we have much of zeros over here, 3 3 6 and 7 8 9 3 3. Why we have 3 here? It is 3. Okay, we only get the maximum part, so here it would be mat dot maximum of this element and this element. If one is present, then it is correct, and then for all the other values, why it is wrong? We are sorting our array and then we are calculating the answer, right? Let's check for the second case. Why it is 2152? So my array would be 1 2 2 5, and I'll start from this 2. I'll start from 2 if I'm having an odd value. Let's quickly print the array over here. What is the silly mistake that we are doing? We are always adding plus I, which is correct indeed. But what if it is even? Then it would be 1. I just want to stop this. Two 7, and we got our answer. Where is it? We got too late submitting this. Okay, the second solution passed.